Hello everyone. In this program, what I'm going to tell you about is how Seidal runs, how Gauss Seidal method runs. Here I'm going to explain it with two illustrations over here. This is my particular program for Gauss Seidal. I've written it with the help of Gauss Seidal algorithm. So for the first thing what I have done here, it is a Python program, and what I have done here is import a numpy. Importing numpy means I am going to use an array over here, and numpy is a library for me for the array. Now the next thing what I've done over here is taking an input n. N is my number of equations or a number of variables that I have to find in the particular equation, in the particular set of equations I'm using. Next, A is my array of the equations, array of the coefficient of equation. It is an n by n plus 1 array. N means here is the number of rows and n plus 1 is the number of columns. Here I am taking number of columns to be n plus 1 because here I am storing the solution for the particular equation as well. Next, this particular section of the code is to take the input from the user, from you as well. Next, I am taking an array D to be of size n by 2, n into 2. That is, n is the number of rows and 2 is the number of columns. I am taking D an array because to compute the value in the Gauss Seidal iteration, and the size of the array to be number of columns is 2, because what I am going to do is Gauss Seidal is take 2 columns at a time and then compute the difference between 2, and if those 2 columns have the difference to be 0 or less than 0 or greater than 0 and 0 or between the range 0 and 0.0001, that is my allowed error, then that is my particular solution. So first I am taking I to be 0. Now entering this particular block of code, this is going to compute my D according to the Gauss Seidal algorithm. Here if I is equal to 0, and this particular block of code is going to compute that if my difference between the 2 columns that I have used, that is D of 0 and D of 1, is less than 0 or is between the range of 0 and 0.0001, then I've got my solution. Now coming to the particular algorithm that I've written over here, the space complexity here is if I'm going to compute the space complexity here, it is going to be, first I have taken an array over here. So if I'm going to compute my space complexity here, the permanent variable that are going to be stored in the memory are this particular array that I have taken from the user over here and D. Now the block of this array is n into n by 1, so it would be n square plus n plus the value stored or the space used by D is n into 2, that is 2n. So overall my equation would be n square plus n plus 2n. So if I am going to take the bigger notation for my space complexity, it would be n square. Now talking about time complexity, I am using a loop over here from the range n. Here I am using the loop n 0 to n, and here as well I am using the loop 0 to n. So in this particular loop or in this particular block of code, my time complexity would be n square, and I is my maximum number of iterations that I am going to use in this particular code. So the time complexity of this algorithm or this program would be n square into I. Now if I am going to run this program in my command prompt, here I have already written the Python command for running the program. So first of all, it is asking me the number of equations in my question. So in my first illustration, I have 3 equations who are having the coefficients to be, first coefficient to be 20, second coefficient to be 1, third coefficient to be -2, and the solution for this particular equation is 17, which I am going to take in the particular array itself. Now in the next equation, the first coefficient is 3, second coefficient is 20, third coefficient is -1, and the solution for this particular equation is -18. In third equation, first coefficient is 2, second coefficient is -3, and fourth coefficient is 20. Sorry, third coefficient is 20, and the solution for this equation is 25. So here I have given my equation over here and the coefficient of equation, and my program has computed me the solution for that. The value of the three variables that I've used, that is x1, x2 and x3, at iteration number 5 would be this. So this is my solution. Now taking another illustration for the same program, I am having my number of equation to be 4. So taking the value of first coefficient 10, second coefficient -2, and taking the values to go on from to last equation. So this I have computed my solution for this particular set of equations as well. Thank you.